So here's a problem. You and your friend play a stick collecting game where you take turns taking sticks from a common pile, and whoever takes the last stick wins. The only restriction is that you can take only 1 or 2 sticks at each turn. This is a problem that's well known among math enthusiasts, a simplified version of the classic game of NIM, which involves multiple piles of sticks. What makes it interesting is that if you don't know the winning strategy, it's almost impossible to win a game against someone who does, even if you're given the choice to go first or not. It can easily feel like some kind of dark magic where you lose regardless of what you choose to do. Today, let's piece together that strategy. My name is Dirdos. I'm on a mission to collect interesting math problems for school-aged children, and I'd like to take you along. If we start with 1 or 2 sticks in the pile, the winning strategy is simply to go first and take all. With 3 sticks, if we assume that our opponent is intelligent and will do what they can to win the game, it becomes impossible for us to win if we go first. Regardless of whether we take 1 or 2 sticks, the opponent will take the rest. Now that we know this about the 3 sticks case, we can use it to win where we start with 4 or 5 sticks. If we make sure there are 3 sticks left in the pile when it's our opponent's turn, they will not be able to win. We run into the same problem again, starting with 6 sticks in the pile. Here, regardless of whether we take 1 or 2 sticks, we can't get the number of sticks down to 3 for the opponent's turn. And since our opponent is intelligent and tries to win, they'll make sure we get 3 sticks to take from at our next turn. In other words, we'll lose if we go first. Here we spot a pattern that repeats with every 3 sticks. While the pile has a multiple of 3 sticks, we can't win if we're the next to make a move. Our aim then is to always give the pile to our opponent when it has a multiple of 3 sticks, which means if it's our turn, and we find that there are 1 or 2 sticks left over from a multiple of 3, we should take them. Then, if we're in the unfortunate situation of having to take our turn when the number of sticks in the pile is a multiple of 3, we do it and hope that our opponent makes a mistake. There, we cracked the strategy. But why multiples of 3? From here, we can try to make minor changes to the rules. What if instead of being allowed to take 1 or 2 sticks at each turn, we're allowed to take 1, 2, or 3 sticks? Again, if the pile has only 1, 2, or 3 sticks, we can just take all of it in one turn. With 4 sticks, we are guaranteed to lose, which means our goal is now to make sure the number of sticks left is a multiple of 4 whenever it's our opponent's turn. We can count on this pattern working for any multiples of 4 because we can always use up exactly 4 sticks in one cycle. No matter how many sticks our opponent chooses to take, we can top it up to 4. And because we're the last to move on each of these cycles, including the last one, we'll be the one to take the last stick. The number of sticks used up in the cycle then will be determined by the range of moves we can make. If we're allowed to take up to 5 sticks, each cycle will use up 6. Up to 10 sticks, we'll use up 11. Now, what if there are more restrictions on what we can do at each turn? If you're enjoying this problem, I made it into a book, so you can share it without giving away the solutions. Check out the link in the description below, and back to the video. Suppose instead of being allowed to take 1, 2, or 3 sticks at each turn, we're only allowed to take 2 or 3 sticks. According to the mechanism we discovered with the previous cases, we would need to divide the pile into cycles of 5 sticks, and try to give the pile to our opponent when the number of sticks in the pile is a multiple of 5. If there are leftovers during our turn, we should try to take all the leftovers so that the pile goes back to being a multiple of 5. What happens when we can't do that? Let's say the game starts with a pile of 16 sticks, 1 more than 15, the closest multiple of 5. We would love to take away the one leftover stick in our first turn and give the multiple of 5 to our opponent. But we can't, because taking one stick isn't an allowed move. Our options are 2 or 3. What now? Okay, calm down and examine the cases. Our opponent, being the intelligent person they are, is also trying to make the pile a multiple of 5 at our turn. If we give them the chance, they will trap us in the losing cycle. Here at our turn with 16 sticks, if we were to take 3 sticks, our opponent will be able to take the remaining 3 sticks and give us a 10-stick pile, eventually forcing us to lose. Therefore, our only feasible choice here is to take 2 sticks. From our opponent's point of view, they now receive a pile of 14 sticks at their turn. They run the same analysis of their options as we did at our turn. If they take 2 sticks, we would be able to also take 2 sticks and give them the losing cycle of 5s. To avoid that, they can only take 3 sticks, which brings us back to 11 sticks, one more than a multiple of 5, just like where we started. We would have to continue this until one of us makes a mistake, giving the other the chance to take all the leftover sticks from the pile. If we both play this game perfectly, the game would end in a draw with a single stick left in the pile, and neither of us would be able to collect it. Phew, math makes sense again. Now I wonder what happens if we have even weirder restrictions on what we can do in a turn. What if we can only take an even number of sticks, or a prime number, or we're not allowed to take sticks more than the previous person? Let me know what you think in the comments below, and until next time, stay curious.